Hello,
Good evening, sir.
good evening. Okay. So we were discussing the acceleration due to gravity changes with height, with the depth. So these are the formulas we have when the acceleration due to gravity is changing with depth. So this is the Earth surface, and here at this point, which is at a distance h from the surface, here we calculated the acceleration due to gravity, and this is come out to be g dash is equal to g 1 minus h by re. G dash is equal to g 1 minus h by re. And what is h? H is measured from the surface of the earth. H is measured from the surface of the earth to the point where we are calculating the acceleration due to gravity. We have completed this question. So today we will discuss this question. Find the weight of a person. Find the weight of the person at depth r by 2 below Earth's surface if weight at the surface is 100 Newton. If weight at surface is 100 Newton. So suppose this is the earth and this is the earth surface, and r is the radius of the earth. They are saying the weight of a person at a depth r by 2. We have to find the weight of a person at a depth r by 2 below the surface of the earth. So this is the surface of the earth. So below the surface of the earth means somewhere here. And what is this distance? R by 2. This distance is r by 2, no? So basically this r by 2 is h. This distance is basically h. This is h. So h is given as r by 2, and here at this point, suppose this point is P. At this point the weight is given. So weight at point P is given as 100 Newton. So weight at any point is equal to mass multiplied by acceleration due to gravity at that point. 100. Oh. Actually, sorry. Weight of the person is given on the surface. It is given. Suppose this is point A. A is a point on the surface, and weight on the surface is given. They are saying find the weight at this point P, and weight on the surface is given. Weight at the surface is 100 Newton is given. Weight at the surface 100 Newton, and we have to find weight at point P. And this point P is at a depth of r by 2. So from this weight, from this value, we can write m into g is equal to 100. So m into g. G is the acceleration due to gravity at the surface of the earth, and this is equal to 100 because weight, this weight is at the surface of the earth. So here means here. So at this point, you have to take the acceleration due to gravity, and that is equal to g. So so suppose this is equation number 1. Now weight at point P, will be equal to m into g dash, m into g dash. Okay. So we will calculate g dash. So g dash is g 1 minus hy re, the value of acceleration due to gravity at a depth h is given by g is equal to g dash is equal to g 1 minus hy re. So this is g dash and this is g 1 minus, what is h? H is r by 2. R by 2, and radius of the earth also we have taken r. So this is g dash is equal to g, this is 1 minus r, and r will be cancelled out. So we will have 1 minus 1 by 2 means 1 by 2. So g dash will be g by 2. So weight at point P is equal to m g by 2. mg by 2. So mg by 2 will be 50 now. If mg is 100, mg by 2 will be 50. So it will be 50 Newton. It will be 50 Newton. Now variation of g uh, due to shape of earth. Due to shape of earth. We know that earth is not a perfect sphere. This, in actual, the shape of earth is like this, elliptical shape. Elliptical shape. This is equator and this is pole. This is radius of the pole. This is radius of the equator. Okay. Radius of the pole, RP, radius of the equator. So we will compare the value of acceleration due to gravity at equator and pole. So the value of g at any point is given by gm divided by r square, and r, if you are calculating at equator, g is equal to gm divided by r square, and this is earth. This is earth. The mass of the earth will remain constant and g is also constant. So this g will be inversely proportional to r square. Now you can see here radius of equator is greater than radius of pole. Radius of equator is greater than radius of pole. And g is inversely proportional to radius. So you can say the value of g at equator will be less than the value of g at pole. Means g at pole will be greater than g at equator. Okay, from equator to pole, what will happen? The radius will decrease. So if the radius will decrease, the acceleration due to gravity means g will increase, because g is inversely proportional to 1 by r square. Okay, now this result is also experimentally true. This result is experimentally true. But when we find it out the value with the help of the calculation at equator and pole, and when we find it out the value with the help of the experiments, we see there is a large difference in the g value. There is a large difference in the g value. So experimentally, g at pole and equator This is experimentally we have find it out G, the value of G at pole and equator, and this is G at pole and equator. We have calculated with the help of the calculations. Okay. And we have seen a much difference was there between this G and this G. There is a much difference. Now, why this difference occurs? Why this difference occurs? Because when you are here or when you are here, when you are here or when you are here, or at any point on the surface of the earth, we know that there is a rotational, means there is an angular velocity of earth. Hmm? Earth is rotating about its axis. Hmm? Earth is rotating also about its axis. So due to the rotation of the earth also, the acceleration due to gravity changes. That is why at equator and at pole, when we find it out the value uh, by experiment, okay, and when we find out the value by calculations, so there is a much difference in the value, because when you are finding out the value with the calculation, you are not considering the uh, rotational effect of the earth. Hmm? So this is due to the rotation of earth. Rotation of earth also affect G value. Rotation of earth will also affect the G value. After that, now we will discuss the rotation due to the rotation of the earth, how the acceleration due to gravity will change. This is the earth, and this earth is rotating with an angular velocity of omega. Okay, so we can find the angular velocity of omega. Hmm? Earth is rotating about its axis. Earth is rotating about its axis. So the time period of the rotation of the earth is 24 hours. Mean in 24 hours, the earth complete one rotation. So with the help of this, we can calculate the angular velocity. So angular velocity is 2 pi by omega. Oh, 2 pi, angular velocity is 2 pi by t. So omega you will get from here 2 pi. Time period is 24 hours. And now you will convert this 24 hours into second. So you will multiply 60. It will be minute. It will be. So this omega is, this value is much less than 1. This value is much less than 1. Means omega of the earth rotation will be a small value. Okay. Now I am taking any point on the surface of the earth. Suppose I have taken this point on the surface of the earth. This point on the surface of the earth, and which is making an angle theta with this axis. With this axis, with horizontal, you can say this point P is making an angle of theta. So on this point P, uh, what what are the forces that will be that are acting on this point P? So now Earth is rotating. So if a mass will be there, we can consider a mass there. Okay. Suppose at this point P, there is a mass M placed. Hmm. At this point P, suppose a mass M is placed. So what will happen? Uh, there will be one force that is equal to weight of this mass in this direction, M into G, and another force will be the centrifugal force, because as the earth is rotating, this mass will also rotate in a circle. This mass will also rotate in a circle. This mass will also rotate in a circle. Suppose this circle in which this mass is rotating having the radius small r. So on this mass there will be a centrifugal force. On this mass there will be a centrifugal force in this direction away from the mass, that is m into r into omega square. Now here you can see on this mass m, one force is acting in this direction, mr omega square, and one force is acting in this direction, that is mg. This mr omega square will be less. The value of mr omega square will be less because omega is much smaller than 1. So when you will do square of omega, the value of omega will decrease more. So basically this force as compared to this force is uh, greater. So when you will find the resultant, so somewhere here like this you will get the resultant here, and that resultant will be mg dash. Okay, so I am not driving this. I have just given the idea why due to the rotation of the earth, the value of acceleration due to gravity will change. Because in this direction, there is an centrifugal force that will affect the value of g. Okay, due to that, this force will affect the value of the acceleration due to gravity. And final expression you will get at this point uh, P, the value of G, that is G dash, is equal to G minus R omega square cos square theta. So this is the value of G due to the rotation of the earth at any point on the surface which is making an angle theta. Okay, so this is the equatorial point and this is the point, this is pole. This is equator and this is pole. So now if suppose we are calculating the value at equator, so at equator when we are calculating the value, this theta will become 0 degree. So this theta is equal to 0 degree. Now put the value of theta here. So you will get g dash is equal to g into r omega square cos 0, and cos 0 is 1. So the value of g dash will be gr into omega square. This is the value. Now at pole, when you will calculate the value at pole, so at pole this theta will become 90 degree. So theta will become 90 degree. So this theta is 90 degree at pole. So put this theta here in this formula. So it will be g dash is equal to g minus r omega square cos of 90 degree, and cos 90 degree is 0. So this whole term will become 0. So g dash value will be approximately equal to g. So the g dash is equal to g. So at pole, the acceleration due to gravity will remain same. But here, due to the rotation of the earth, the value will change. Gr omega square. R is the radius of the earth. Okay, R is the radius of the earth. Now there is one question on this. What should be the speed of the before that you should know this formula. G dash is equal to G minus radius of the earth into omega square into cos square theta. So acceleration due to gravity due to the rotation of the earth, g dash is equal to g minus r omega square cos square theta. So they are asking what should be the speed of the rotation of the earth, means they are asking omega, and time period of the earth, time period, so that the weight of a person on the equator is zero. So that weight of a person on equator is zero. So I told you that this is equator and this is pole. So I told you if you are taking any point P, this angle is theta. So at equator, what will be this theta? 90 degree. Equator means theta is equal to 90 degree. And the value of G dash here will be this. G dash is equal to G minus R omega square cos square 90 degree. Cos square 90. Just a minute. They are asking so that the weight of a person on equator is zero. So what is the weight? Weight at equator. Weight at equator. Weight at equator will be mass of a person multiplied by acceleration due to gravity. There, mass of a person multiplied by acceleration due to gravity there, and g dash is the acceleration due to gravity at equator. Okay. Now they are saying weight becomes zero. Weight becoming zero, and this is m, and value of g dash we know. G dash is equal to g minus r omega square cos square theta. G dash is equal to g minus r omega square cos square. Now this theta is 0, not 90. Okay, this theta is 0 at equator. Here this theta will become 0. So cos square 0 you can put, and cos 0 is 1. So this whole value will become g is equal to r omega square. They are asking omega. So you will get omega is equal to g under root g by r. Now time period you can find t is equal to 2 pi by omega. So from here you can get 2 pi under root r by g. Okay, Eva? Okay, please take the screenshots.
We scroll down a little bit.
It will be g by 2. You can write this 50 Newton. Okay. Okay, please take the screenshot of this.
Answer.
Okay, this one.
Answer.